today is direct variation. This is the equation for direct variation. It's just like y equals mx plus b, except there is no b. That's the only difference. And for some reason, instead of putting an m, they make it a k. But k is going to be the constant. It's just like the slope. Okay, so anytime they ask for constant, I know it doesn't start with a k, but it sounds like a k, so that'll make it easier to remember. So constant is k. You cannot have any b. You cannot have any number after the x. So no plus or minus anything. The other thing is x cannot be at the bottom of a fraction. It's okay if it's at the top, but your x can't be in the bottom. So those are your two rules. We can't have any number past the kx. Usually k is going to be a number like 5. So y equals 5x. It can't have anything else after it, and it can't have x at the bottom of the fraction. Okay? So you'll see these things. There are two different IXLs. It'll say determine if it's a direct variation and verify by a graph. So in other words, what we're going to be doing is we're going to be graphing. So if you graph, all you have to do is stick them in Desmos and find me some points. So a couple of points if you plug this into Desmos, or you can use, if you like the tables, you can use that and do things like this. So if you get a table, this is what your table would look like. So you can do 0, 0, 1, 2, and 2, 4. So remember that these are the x's and these are the y's. So 2 on the x-axis is here. 4 on the y-axis is up there. So you just connect your dots, and that's it. The reason why this is direct variation, and this is really important for the graphs, is it has to go through 0, 0, 100% of the time. If it doesn't have 0, 0, it is not direct variation. Okay? Very important. So that's all we're doing with that one. Over here, again, whether you want Desmos or whatever, if you look at your table, some of these might be decimals, which is fine. I'm going to plug in 0, and if you did 2, you would get 1, and if you did 4, you would get 2. So you add 0, 0, which shows that it is direct variation. 2, 1, and 4, 2. Okay? So this verifies its direct variation because it goes through 0, 0. So up here it says determine if it's direct variation. So in this case, for both of them, since they go through 0, 0, this is a yes, it is direct variation. Same with this one, it is a yes, it is direct variation. It goes through 0, 0. Plus we didn't have the two no-nos. The two no-nos were you can't have anything after it, and you can't have x at the bottom of a fraction. It's okay if x is at the top, it just can't be at the bottom. All right. Next, boom, big red flag right there. X is at the bottom. So this is not a direct variation equation. Okay. So if I plug in 0, this is going to say undefined. So if you ever plug it in your calculator and it says error, it's undefined. If I plug in something like 2, that's going to give me 1. And if I plug in 4, that's going to give me 0.5. So I can't do anything there. If I graph 2, 1, it looks like this. 4.5, it looks like this. And if you graph this in Desmos, it's a really crazy looking graph. It's actually broken up in 2 parts. It'll look like this, and there actually will be something on the other side as well. So if you graphed it over there, it would look like this. This is what the one graph looks like, so it's really weird. And it is not direct variation. So no, I verified it with my graph right here. You have Desmos, so just find some points and plug them in. Okay, over here, this is the no-no. You can't have anything after the x. If you're looking for the constant is 1, which is fine, but you can't have this. This is a no. So if you picked a few points to graph in Desmos, it could be 1, oh, I should do 0. 0, -4, so see, it's not 0, 0. That's how you know it's messed up. 1, -3, 2, -2. So if I graph those, I'm here, here, and then 2, -2 is there. So if you notice, this does not go through 0, 0 like it's supposed to. So that's also going to show it that it's a no. And this also doesn't go through 0, 0, which is why it's a no. So you can always check it in Desmos in the graph to see if it works or not. Graph it, see if it goes through 0, 0. It should just be a straight line through 0, 0 for it to be a yes. Okay, that's the first part. Second part, we're solving. So it says y varies directly as x. So all that means, when you see all of that, y varies directly as x, it just means we're using the direct variation equation. So we have to solve using that. Then it says state the constant. So that's why I'm going to use the equation so I can find what k is. So here's what it says. It says y equals 4 and x equals 2. So what I'm going to do is I'm going to make a fraction. So I'm going to put the y. The ones that say when, those are the ones that go on top of each other. So 4 and 2 go on top of each other. And then I'm going to keep the y's on top. Then I'm going to find y. I don't know what y is. And I'm going to keep the x's on the bottom. This is called a proportion. So this is just our setup. The ones that go together, they go on top of each other. If you put y on top, then you got to put y on top in the other fraction. And then, do you know how to solve this? Is cross multiply. So if I cross multiply, 2 times y is 2y. And 4 times 16 is 64. Okay? And then all you got to do is solve. So if I divide both sides by 2, y is going to be 32. So it says solve. Here's my solve part. And then it says state the constant of variation. So the problem is if I state the constant of variation, I got to figure out what k is. So that's the problem with these ones. So to figure out what k is, I just need to take an x and a y, a combination like these two, and plug it in. So y is 4. I don't know what k is, and x is 2. So one step, all I got to do to solve is get k alone. There's my constant of variation. So 2 answers I had to solve. That's y equals 32. My constant of variation is find k. So we're going to do a bunch of these. I put a bunch of them on there. All right, next. Y is 9 when, so they're connected. 9 on top, -3 on bottom. Okay, and then I'm going to do x. So this says find x. Remember, x is on bottom. And then y is 6. So don't get confused when they stick them out of order like that. If you put y on top, keep y on top. All right, now if I cross multiply, I got 9 times x, 6 times 3. So here's my solve part. Okay? Then I can plug into here. So I'm just going to pick a combo like this. So y is 9. X is -3. So all I have to do to solve for k is divide by -3. And that's going to give me -3 for k. So there's my constant. There's my solve part. Okay? So I've got 4 more of these. So I'd like you to try them. Pause me, try them. I'm going to plug them in as well. So y is 9 when x is -3. Wait a minute. That looks very similar. Yep, that's the same problem. We're skipping that one. Okay, over here. Find y when, so y, I don't know, when x is 3/32. And then, so it's weird because it's a fraction and a fraction, but we'll deal with that. And then I've got these two that are connected, 1/4. So I kept my y on top. And then x is 1/8. Now, if you don't like these, change them to decimals. Use the decimal. But if it's a decimal that goes on and on and on, you're going to have to use it and plug it in, the whole decimal. So if you cross multiply here, I'm going to get 1/8 y. And then over here, if I do 1/4, that's going to give me 3/128. Okay? And I don't think that reduces. So I'm just going to leave it like that. Now, to solve this, remember, if you have a fraction, get rid of the denominator by timesing by it. So that's what I'm going to do. Now I got 1y, which is just y. And if I times here, that's going to give me 24/128. Now, if you have a calculator, it's not going to tell you that. It's going to reduce it for you, as it should, and as you should as well. So let me go back. So if I divide that, let me see. I think they're both divisible by 4, actually. If you have a regular calculator, you can math enter it. Desmos will do it for you. So if I divide by 4, that's still not doing it. Divide by 2. There we go. So you should get 3/16. If you did the decimal, I don't have my calculator around, so I don't know what that decimal is. So if you do the decimal, that's fine. It should be the decimal of 3 divided by 16. Okay? Then what I can do is I can take the y and the x like this, so that I can find my k, my constant of variation. I'm going to do it over here. So remember your constant of variation, y is 1/4. and then x is 1/8. So to solve for k, just get rid of that fraction. Times by the denominator. So if you times 8 times a fourth, you're going to get 2. And this is 1k, so you can just say k and be done. Those are your two answers. Okay, 2 more. Pause me, try them. So I'm going to put 3. This is x. Here's my when that connects them. 3/12. I put x on top, so this x goes on top and this y on bottom. Cross multiply, you get 12x. 3 times 8 is 24. So your solve part, if I divide both sides by 12, that's going to be 2. Okay, let's go back to our direct variation equation and pick a pair. So my y is 12. My x is 3. And if I just divide both sides by 3, that will give me my constant of variation. So k is 4. Okay, try one more. So I've got, here's the when that connects them, y. So I got y over 10. This y over this x. Okay, cross multiply. I've got 15y. 6 times 10 is 60. And if you divide, you get 4. So divide both sides by 15 to get 4. Okay, pick a pair. And then this is going to be with my direct variation equation. So y was 6 and x is 15. So it may not always be pretty because this time when I divide, you're going to get a fraction, which is okay. So divide by 15 and you're going to get 2/3. Or if you do it in your calculator, it's going to be 0.6 repeating. So you can just say 0.7 if you want to do the decimal. I'd recommend you do the fraction because if you round incorrectly with the decimal, like if you say 0.6 instead of 0.7, when you round, then I'll probably take a point off. So when in doubt, use the fraction and use Desmos. You're allowed to. Okay?